Okay, thank you for coming to this session. We're super excited to be here at KubeCon to tell about Kubernetes, about GitOps, and about the container build tools that you can use together with these GitOps tools. Need to speak louder here. Okay. So a little bit about ourselves. We work at Branch Metrics. I work in cloud operations, and I work handling lots of containers on a daily basis. We're running API services in Kubernetes and running our data pipelines, also some in Kubernetes and some on top of Mesos.
I'm Javeria, a systems engineer also at Branch. I am responsible for building and maintaining our Kubernetes clusters. I also spend a lot of my time focusing on improving our infrastructure's productivity through automation and GitOps.
So a little bit about Branch. We run containers pretty much everywhere. Are you calibrating? So. We've been running Kubernetes for about 3 years in production. We run pretty much all of our API services in Kubernetes. We serve lots of different languages. Our main Hello? We're having some technical difficulties. Yeah, cool. Okay, so our main CI/CD system is Circle with Jenkins, and we use GitHub extensively. And then we're using tools like Flux and Bazel, and then we have some homegrown tools that predate some of these GitOps tools that we use to build and deploy. And also our big data pipelines are fully integrated with CI/CD. All the pipelines run in Spark and Flink. A little bit of what we're going to be talking about today. So briefly touch on our scale and some GitOps history. Then we'll dive into the tools. Why do you want to use these tools? We'll do some side-by-side comparisons. We'll talk about some pros and cons, and then we'll talk about the container build tools. Again, why to use them, and also side-by-side comparisons. And then we'll talk about which ones you may want to choose in terms of community support, which one might be easier to use, which might be more stable, and which might be sort of production ready. And then we'll talk about some future enhancements. So Branch, so we have a pretty large scale. I mean, it's not the largest in the world, but we have about 10,000 of containers per cluster. We run about 10 Kubernetes clusters, serving 8 billion requests a day, processing about 10 terabytes of data per day, 200 microservices, and we run about 300 plus builds a day. Some of the GitOps history, in 2003, BuildBot was released as kind of like the first GitHub or CI/CD tool that I heard of, and it's actually being used in a lot of places today. It's pretty bare bones and written in Python. Then in 2011, Jenkins and Travis came into the world, and then Jenkins, that's when it became the de facto standard for CI/CD, and Travis also for like GitHub type of applications. Then in 2013, some more cloud providers started to come up with their solutions like Circle CI and AppVeyor, and those were like more like SaaS type of services, and later they provided more like on-prem services. In 2011, Kubernetes released its 1.0 version, and that's when everybody started talking about, deploy to containers to in an automated way to a cluster. And then in 2017, GitOps was coined as a term primarily by the folks at Weaveworks, and that became sort of a way to deploy to a Kubernetes cluster. Yeah, so lots of options, lots of different tools. So hopefully in this talk you'll learn about them, and if you're currently using a tool, hopefully you can maybe see if you can improve it and maybe contribute back to the community. If you don't know anything about any of these tools, hopefully you can pick one of the tools to use in your environment. And if you are currently having your own infrastructure CI/CD, this session will be more for informational purposes. So. And now I'll hand it off to Javeria. She'll talk about the GitOps tools.
Hi, everyone. Thank you for attending our session. In this short half an hour, I will first review some GitOps tools, and then Rico will cover the image building tools. While this isn't enough time to cover more of this landscape or even go into more details of any of these tools, please feel free to catch us afterwards for more questions. So to begin with, why use GitOps in the first place? Like Rico mentioned, this term was originally created by the Weaveworks people, but it has since then gotten much more popularity, with a lot of tools now offering automation support for deployments and config updates. So, but in essence, the idea is that you version control both your infrastructure and your code. And that way, you can then use a GitOps tool to compare your current state of your cluster or your code to the desired state in your version control system. By automating your deployments for cluster updates or for code versions, you gain, first of all, reversibility because rollbacks are now easier. You have the previous version in the source control somewhere. You get an audit trail, which is good because everything goes through PRs and you know who did what at what time. And most importantly, teams gain transparency because now there are no more obscure system level changes that only one person knows how to do. So why is config updates and code deploys an issue that merits another full Kubernetes KubeCon presentation? Well, just for some background, we showed some numbers earlier, but here at Branch, we've been running our production cluster traffic through Kubernetes since 2016. We have about 10 clusters, and each of these clusters have about, or the larger of these have about 200 different applications deployed to them. Like Rico mentioned, our CI is a mixture of Circle CI and Jenkins, but we have a build running almost every 5 minutes. So to build a sustainable and stable system from the ground up to this kind of traffic is hard. But luckily, the cloud natives landscape now has a bunch of tools that can help you on this journey. So if you were using GitOps practices in your infrastructure, this is what it could possibly look like. So your developers would do their pre-prod tests and development testing on their laptops, and then they would use image building or app development tools to build that source code into containerized applications. Those containerized applications could either run directly on their laptops or they could run on remote dev clusters. Now, some of these tools, as I will show later, also further help automate this process by providing iterative update support so they can update the remote changes from your local changes either to the repo or running your source code or either to the remote apps that you're running in the remote dev cluster. They can also help integrated testing by port forwarding those remote apps to your local dev environment, to your laptop, and they can also stream those remote logs for you. So when all of this is done and tested, that code can now be pushed to the code repos for production PRs. And then your CI system, whatever it is, can then run further testing and building on that code, eventually pushing it to new images in your private Docker registry or whatever you're using for that portion. Once you push those new images to the registry, you typically, ideally, have controllers running inside your cluster that are watching these private registries for new images. So as soon as new images are seen, it can update your cluster apps with the new images automatically. Another good thing to do here is not that any of these tools that we've seen provide it. We have a homegrown solution for this. But if you had a controller or something that's part of the sync controller also watching those rolled out apps, and it could see if there were any issues through a cluster monitoring tool such as Prometheus, and if it found any issues, it could roll back those apps for you. Similarly, config or the cluster config, such as a Kubernetes manifest for deployment files or services or load balances or ingresses, is also kept in source control. And those repos are also watched by similar but other kinds of controllers that can update the cluster config as soon as you push changes to those repos. So while a lot of these tools have common features, they are not exactly interchangeable. I like to categorize them into 3 main groups, with the innermost layer being templating tools such as KSonnet and Helm. So what these basically provide is a way to define your applications, and they sort of make it easier to define multiple versions for different clusters that you might deploy them on. A layer above this is app development tools such as Draft, Gitkube, Skaffold. I will come to those later. But these are meant to target the inner workflow of a developer when they're still working on their code, when they're still testing it, and before they actually push it to the final production system. And the topmost layer is the deployment tools such as Flux or Algo. These are the controllers that you would typically run in your cluster. These help to keep your cluster state in sync with the config that you source control. Among all of these tools, the way that we're going to rank them is according to these common traits or features. First of all is dependencies. So how many things does it make you install, and how many things do you have to learn for that tool? And then does it handle source control, and is there iterative development support? What that means is once the developers are working on their local laptops, does that tool support updating their repos or updating their remote dev versions from the source control on their laptops? Do these app development tools also support local development versus remote testing and development? Logging, which is very important, as any sysadmins in the audience will agree with me. We need to know what happened where and who did it. And then lastly, how stable is the tool? What version is it on? Is there a community? And how easy is it to get support for that tool? And lastly, is it recommended to be used in production or not? So coming to the actual tools themselves, this is by no means an exhaustive list. These are simply the tools that we've had an occasion of using, and also simply ones that we've found to be more popular in the landscape at the moment. So I'm starting with the templating tools. KSonnet is the first one. It's meant to be an iterative process for declaring applications. This punchline here is from a talk by Brian Lyles from the European KubeCon earlier this year. So their idea is that YAMLs are harder, and KSonnet or JSON is for people when they want to define their apps. So it was created by the people at Heptio or Bitnami. It's basically a way to define app because it's a templating tool. It's meant to be an alternative to kubectl or Helm. The way you do that is through JSON manifest. So this tool is great if you hate YAML and you don't want to use YAML in your manifest definitions. JSON is basically a fancier superset of JSON. And there is no Docker file requirement because this is not an image building tool, and obviously you don't need a local Docker daemon running as well. You can do local and remote support with this. Sorry.
Problems.
Is there a different network you can connect to? I can turn it on and off again.
You try turning it on and turn it off again.
There's a different Wi-Fi we use, the 2.4.
Yeah.
That one.
It may work.
If everybody can get off their Wi-Fi's.
Do you know what the password is?
Cloud native.
Okay, it's fine. Sorry about that, folks. We were talking about templating tools, and I had just started with KSONet. So you use this if you hate YAMLs, and you can define your applications in JSON. The best thing about this tool, the nicest feature I found, was it has a dependency package management system where you can reuse your code in other KSONet applications, and it supports GitHub, file system, and Helm repositories. So you can pull down your KSONet packages from these. It does have a dependency of knowing how to use JSON, but that isn't actually a con, because obviously the idea of using this tool is if you wanted to use JSON in the first place. It does have an active community, but remember this is still a very early 0.13 release. It's a templating tool, so it does support deploying to multiple clusters with multiple versions of the same application. It doesn't handle source code updates at all, and we wish it had an integrated image builder, which would have made this nicer. Okay, the next one is Draft. Draft is an app development tool. It's sort of meant to be used for streamlined application development. It's on the app development layer, the second layer that I showed. It's a Microsoft Azure open source project, and it's basically used to build your application and then test them on a Kubernetes cluster, a remote one or a local one. You don't have to use a Docker file, but you can make one and use one. It has local and remote support, like I showed in my diagram earlier. You do need a Docker daemon running locally to build your applications. The best thing about this tool is that it supports all of these mainstream popular development languages at the moment, like Clojure, Gradle, Java, Ruby, Swift. And so good things about this tool is you don't have a Docker file requirement, but you can use them. You also don't need the Kubernetes manifest already created to be able to use this tool, because it just basically builds in your source code and creates containerized applications for you. You need to have Helm and Tiller installed for this. That's one of the dependencies. And you do need a local Docker daemon running. It obviously has an active community, but it's still a 0.16 experimental release. The best thing, like I showed earlier, is that it supports many languages, and it has an integrated Docker image builder, so you don't have to use any of the image building tools that we talk about later. However, it does not support iterative updates, and you can't update your source code or remote stuff through your local code. So it doesn't manage your source for you. The next one is Gitkube. So this is also an app development tool. The idea here is that it's a wrapper for your common tools like Git and kubectl. It was created by Hashura. It's at the app deployment layer, and the way you do this is for Git. You use git push to do this, to do the deployments. You do need a Docker file, and obviously you need a daemon running in your cluster and locally. And it supports local and remote development. The way this works is you have three main components that Gitkube uses. You put a controller in your cluster that watches for changes in your remote CRD that you define. So the remote CRD basically was you define what kind of changes and what actions it will do for any things that you push to the repo keeping your changes. As soon as it finds changes in your repo, it'll roll out those deployment changes for you. The best thing about this tool is that it uses commonly used tools already, like Git and kubectl. It's very easy to set up. It has RBAC support, so you can put in the appropriate security measures for your installation. It supports any language, is also great. It also handles your source code, so it has source code management. It doesn't have a CLI, it runs directly on the cluster. It is still a very early 0.2 release, and there isn't really an active community around it. You do need remote Docker, and you need Docker files, and you do need your Kubernetes manifest in your repo to get this up and running. Sorry for that again. The next one is Flux. This is purely a deployment tool. This is by the people at Weaveworks. It gives you automated synchronization for your cluster and the stuff that you keep in source control. So it was created by the Weavework people. It's a deployment tool, and basically you use git push or the Flux CTL. It has its own CLI. To apply these changes, you don't need Docker files because it is not an image building tool, and you use git for the local changes, and you use the Flux CLI for the remote changes. You don't need the Docker daemon, obviously, because it's not an image building tool, but you can combine this with any of the tools that Rico mentions later. The good things about this one is that it's easy to deploy, the controller, and the CRD. It supports Helm charts natively, so it doesn't matter whether you have your deployments in YAML or in Helm. You can use their Helm installer. The best thing about this is that it manages your source control. It's automatically synced with whatever you have in the VCS to your cluster. It's a very stable, very mature release. They have an active community, and support is easy to find. The cons, however, is that it doesn't actually do local Git management. So any changes that you have locally do not get synced automatically to your repos. There's no image builder. That would have been much nicer if this also built the images for you. Another concern here is whether it scales or not, because you can only deploy one of these controllers per cluster, and it has to work with all of your namespace. So there's some fancy things that you can do with RBAC roles and namespace whitelistings to get around that. But the other thing is that rollbacks are hard. So if you have the automatic thing on for this tool where it pulls in images as soon as it sees them, it's hard to roll back because you have to first de-automate that deployment, and then you roll back to your previous version, and then you automate it again if you want it to be automatic. So while it's possible, but we find that slightly not straightforward. The other thing is that if you're doing more fancier deployment models, such as canaries or blue-greens, these also become harder, because it's meant to sort of just watch for images and apply the newer images as soon as it sees them to all your deployments. The way it does this is, this sort of ties into the first diagram I showed, but you have a controller running within your cluster called a Weave Flux controller, and it watches your config repo, and it watches your Docker registry as well. So as soon as you have new images in your Docker registry, it'll apply those images to your deployments if you've set them to automate. If you haven't set them to the automate mode, you can do that manually. So when you know there are new images and you want your deployments to get updated, you use the Flux CTL CLI. It also watches your config repo. So for any changes that people do, if they add new annotations or new environment variables, now those things are source controlled, and you know who did what when. And this actually is what I think is the best thing about this tool, is that you can use this config repo to apply your cluster updates automatically. Second last one is Skaffold. So the best thing about this tool is I think it's the most well-rounded tool. It's for app development and deployment. It was created by Google Cloud. You do need Docker files, and you do need the Docker daemons running because it builds the images for you, but it supports local and remote development. So it has a controller, and the best thing about it is it obviously supports any language. It has a very active community. Support is easy to get. It is still an early release, 0.16, but it automatically updates the remote from your local source code. It has an integrated Docker image builder. You do, however, need local Docker, and you need Docker files, and you need Helm and K manifests in the repos that you set up for Skaffold. So another good thing about Skaffold is that it can support the whole build pipeline with any tool that you use at any stage. So for example, if you were doing just local development, so it can use local Docker daemons, or if you were doing it for remote deployments, it can use any kind of builder for your cloud. And then eventually for the deployment part, you can use Minikube or kubectl or Helm, or however you choose to do your deployments. So it supports all the popular tools at any stage of the build pipeline. Argo is a tool for, it's actually a workflow tool, so it doesn't actually do any development or help with the actual deployment process. It's slightly different from the other tools, but it was created by the Applitix people. It's used in CI/CDs mainly, where you can use it to define workflows for your build pipeline. And it has a controller. You don't need Docker files because it's not building images for you. And you don't need the Docker daemon. It's declarative YAML, and it supports pipelines. The good thing about it, it has a very nice UI. Kubernetes is already integrated. It's a mature release. They have a community. It is very active. This, however, like I said, it's not actually a deployment or development tool. It's more of a workflow tool, and it's kind of like a CLI for kubectl. The other con is that it does have a slightly complicated setup, but you can use it for creating DAGs and applying those workflows from those DAGs to your cluster. The last one is Metaparticle. This one is actually slightly different from the rest, as in it was created by Brendan Burns, and it's used for templating and deployments. The different thing here is it's great if your developers don't want to know how to actually use Kube manifests or how to use Dockers or how to build images. So it abstracts all of those details, and you get native language modules within each kind of source code that does all of that stuff for you. So you use actual source code for Java or Python, and those modules will take care of all the Docker image building and the deploying for you. You don't need the Docker daemon, and you don't need the Docker file because it abstracts all of those details. So it has a YAML format, and it's basically infrastructure as real code. So it supports a few languages right now, which is sort of constraining because there's not a whole lot of support, but there's more coming in the future, especially Go, Rust, and Ruby. And it needs a local Docker daemon running, which is a con. Like I mentioned, it has very limited language support. It's very alpha. There's no community support is hard to find for this tool if you choose to use it. So this is just a side-by-side of all the tools we already discussed. And now I will hand it over to Rico to take over the image building tools and to give a final analysis of what we think works well in production.
Okay, so now let's talk about container build tools. So I'll talk about these. You got Kaniko, you got IMG, you got Orca with UMOCI that work together, and you got Builda. Then there's Faster Than Light, and I'll talk about Bazel with its Docker and OCI module. So the question is, why do you want to use some of these container build tools instead of just running Docker build? One thing that you may want to have is faster builds. There's no guarantee that you're going to have a faster build, but most of these tools will build faster than plain Docker build. And then this is dependent on the type of application or the type of dependencies in your container, but most of the times you'll have something built faster. Another aspect is that you may want to run your container builds in an unprivileged way, so you may want to say that this is more secure. Right? Another aspect is you don't want to use Docker in Docker to build in your Kubernetes cluster. So you can build, with these tools, you can build in a Kubernetes cluster, non-nested, not in Docker, and build images in slaves and Kubernetes pods. And another aspect is more related to Bazel, is that you may want to have reproducibility. You have maybe sometimes you build or run make inside a container. So instead of running make, you can run something like Bazel and have something reproducible with that build. So Kaniko, so created by Google Cloud, it allows you to build container images very fast. It supports either a local file system or Amazon S3 or Google Cloud Storage, so object storage. And then it does it using a Kaniko executor image. It's its own container image. And you can build both unnested way and also in an unprivileged way. IMG, another tool, is created by Jesse Frazell. It also allows you to build containers. And you can build them in an unprivileged way, but the thing about this tool is that you build the containers in a nested way, and it needs access to your /proc in privileged way, so your raw prog. It uses its own CLI, and it doesn't require a Docker daemon. Another tool, Orca Build, that works with UMOCI by the folks at SUSE. And it's a Python wrapper on top of some other tools. It allows you to build containers, and those other tools are UMOCI, runC, and Skopeo. UMOCI to manage the file system and the image creation locally. runC to instantiate the containers, and Skopeo to manage the interaction with the container registry. Then there's Builda, created by Red Hat. It also an OCI and Docker image builder, so it supports both formats, OCI and Docker. It has its own CLI, and it goes along with its Podman application, its Sidekick application that you can use to run the containers. Another tool is Faster Than Light. It's created by the folks at Google Cloud. It's very fast. That's where the name comes from. It's build container images very fast. The only thing about this tool is that it has these specific runtimes like to build the container images in Python, PHP, and Node.js. And how does it do it? It has its own CLI. There's no dependency on the Docker daemon or the Docker file. It has its own way to push automatically to a registry. Then there's Bazel with OCI and its Docker module. Bazel is a tool created by Google. And the OCI module allows you to build images unprivileged and also very fast. And one of the interesting things about Bazel is it allows you to have your build be reproducible and deterministic. And you can totally take advantage of that to build your container images. Then there's Knative. So created by the folks at Google Cloud, and pretty much is running serverless in Kubernetes using templates. And there's templates for some of the other tools like Buildup, Bazel, Kaniko, and some others. So if you look at side by side some of the image building tools, you see created by different people and organizations. So you can see pretty much all of them allow you to build. Some of them allow you to just build in, or specifically build in a Kubernetes cluster. And then they have different ways of building the images. Kaniko, it's unnested and unprivileged. IMG, it's nested and it's access to raw proc. Then you got something like Buildup that requires privilege escalation. Faster Than Light, it's just with layers and no Docker. Bazel with its own definition files. And then Knative with its own templates. So you see one of the interesting things of these tools is that none of them require you to have a Docker daemon, which is pretty nice, right? So you don't necessarily have to have Docker. And all of them allow you to build in a Kubernetes cluster. It's just that some of them are specific for that, for example, Kaniko, and the other ones you need other ways to build it. So for example, Buildup, you require a Knative template. Faster Than Light, you can do it with Kaniko, and Bazel, you require Kaniko and Knative. So the tools that you can use, the GitOps tools that you can use with the build tools together, so are pretty much the ones that don't have any dependency on building anything, any container. So the top 4 tools are the ones that you can use with any of these build tools. You got Flux, KSonnet, Metaparticle, and Argo. And then you see the bottom 3, you cannot use with these container build tools, Draft, Gitkube, and Skaffold, because they already build the container in. The tool itself builds the container, right? So Draft has its own CLI, and then you say Draft build, and it builds the container for you. Same with Gitkube. Once you do a git push, it builds with a Docker daemon inside a Kubernetes cluster, and Skaffold also builds the container image once you deploy. So what to use in production? What kind of takeaway can you get out of all these tools? So we came up with 3 categories. We came up with like easy to use, more community support, and also what's more ready for production and more stable. These are not actually set in stone. So I mean, these tools are very fast evolving. So it's more like a guidance. So we came up with easy to use in terms of GitOps, Draft and Skaffold and Flux. They seem to be pretty straightforward to set up. So they have their own CLIs, and documentation is extensive. And in terms of image builds, we think IMG and FDL seem to be pretty easy to set up and straightforward. Also, documentation is available on GitHub. In terms of community support, this means maybe which organization is behind it, or how many GitHub starts they have, or maybe how much traction the project has on GitHub. And for GitOps, we came up with Flux, Draft, and Skaffold, which is the same tools that we talked about previously being easy. And in terms of image builds, we came up with Buildup, Kaniko, and IMG. Buildup, Red Hat is behind it. Kaniko Google Cloud is supporting it, and IMG also seems to be very popular in GitHub. And then Flux is supported by Weaveworks, and Draft is supported by Microsoft, and Skaffold is supported by Google. Okay. Can you please get off your Wi-Fi's? Okay, cool. Okay, sorry about that. So, okay, so in terms of production ready, with GitOps, we came up with Flux and Argo. They're like a 1.7, 1.8 release, so they've been around. They've had a lot of iterations. So we think they're stable and then production ready. In terms of image builds, we came up with anything that is Dockerfile or runc based. Those tools have been around for 4+ years, so they would be a good choice for a production type of environments. Bazel also been around for a while and supported by Google, and then same thing with Kaniko for image builds. So for the future, what do we see with some of these tools with GitOps? We'll see more 1.0 releases, as a lot of these tools have like 0.x release, so only like maybe Flux and Argo have later releases. And then we'll see maybe newer tools, possibly tools to integrate with each other, or maybe having a custom resource definition in Kubernetes, or different resource definitions in Kubernetes. And then in terms of build tools, also the same, more 1.0 releases, a lot of 0.x, and again, more tools to build inside the cluster, inside your Kubernetes cluster. Maybe having sort of like a build CRD in your Kubernetes cluster that allows you to do these container builds. And Helm is also in the works. It's another tool being enhanced in V3. The proposal is out, and it'll support plugins and hooks in Lua, so you can write custom code. And it'll have event-driven architecture, very similar to what some of these other tools have, like Flux, where you have an event and something happens, and then deployment gets triggered, or there's a change, and then something gets triggered on your cluster, and a deployment happens. So here are some resources for the GitOps tools, and then the container build tools, and I think that's all we have. I think there's time for some questions if anybody has any questions. Hello. Yeah, the question is, what do we use? So we're using some Flux, and then we're using Bazel, and then we're using a combination of homegrown tools that actually predate some of the GitOps tools, right? So, yeah. Any other question? Can you?
The various GitOps options, one of them was called out as not being very good at doing rollbacks.
Oh, that was Flux.
Are the others decent?
Actually, no, because rollback is more of a deployment feature, so there were only 2 deployment tools up there. We use Flux, but we only use the sync feature. We don't use the automatic image pulling feature. Rollbacks is important because when you're rolling out new code, you think it works in your laptop, and then you think it works in the dev cluster, but sometimes it's always different in the production one. And it's great if you've got something that watches out that rollout, and if there's issues, it rolls it back. So yeah, the other tools don't have that feature either. It's got some of it. You can do a rollback, but you do it slightly not in a straightforward manner. No. We'll upload the slides.